Welcome, and we're on to the 13th of January. Let's go. All right, so looking ahead a little bit. So I've got some questions involving the ratio, and I've got down the bottom what looks like a speed, distance, time. So let's start with the first question. All right, so this first question looks impossible because I've got nothing to do with the x and y. However, what I can see is I want to get x as some function of y or some equivalent. So let's just try and resolve this algebra. So I have 6x plus 4y equals 7, y minus x. Collect my x's, collect my y's. That's going to give me 7x equals 3y. So far, so good. Now, what does this mean? Well, this isn't quite correct, though I'm going to write it, but this is how I can explain it best. If you imagine that 7 wasn't there, then x will be 3 times y. So I could say x is 3 times y. And if you imagine that 3 is not there, then y is 7 times x. So therefore, as a ratio, it must be, so remember, x is 3 times y, so x is 3, and y is 7 times x, that must be 7 times bigger, so therefore x to y is 3 to 7. Nice little question. Next question. All right, so the next question is your quadratic inequality. Now, again, there's a technique to do it, but don't just learn the technique, understand why. I want to find out when I graph this equation where this graph is above 0. In order to work that out, I need to find out where it equals 0. So the way I'm going to do that is I'm going to factorize this equation. And I know from my quadratic algebra that if I factorize it, that when x equals 4 or when x equals 1, this equation goes through the x-axis. I also know it's a positive or happy quadratic, so therefore I know my quadratic is going to look something like this. Now I want to know where the quadratic is above the 0. So it's above the 0 here, and it's above the 0 to the left of 1. So therefore my answers are x is greater than 4 or x is less than 1. On an important point, the reason these aren't less than equal to is because the question isn't less than equal to. So that's why I've got those numbers there. Next question. All right, nice little search question using some Pythagoras. Whenever you get a triangle in GCSE, does it have a right angle? If it does, it's probably trigonometry or Pythagoras, which it is here. Set up your equation nice and clearly. So the hypotenuse squared is the other 2 squared. You don't necessarily need to write that step out, but as long as you know that 12 square rooted squared is 12 and 30 square rooted squared is 30, it's just 12 plus 30, which is 42. But that's x squared, not x. Really, really common error. So therefore, x is the square root of 42, which is going to give me about 6.48. The question doesn't want an accuracy, so therefore 2 decimal places or 3 sig fig is normally the one that we choose to do. You can see I've put approximately. As long as you can see my working, that's okay. That's not too bad. Next question. All right, so we've got a lot going on here. So we've got a speed versus time graph, and we've got changes in speed over time. All right. Then it also tells me down here, tells me the average speed from 0 to t was 5.96. And then the question says find t. Now, from this question, I know that the area under a speed graph is the distance. So I'm just going to note that to myself. So the distance is the area under the curve. However, what I've also got down here is I also have the average speed is 5.96. And I know it does that for t seconds. So therefore, using speed equals distance over time, I know the distance travelled is going to be 5.96 times t. I've just rearranged the speed distance time formula. And that means I can set up a function where I'm doing a plus b plus c, work out the areas of those shapes, and I know the areas of those shapes must be equal to 5.96. So let's write that out. So I've got a plus b plus c. Now let's go through this in steps. So a is a rectangle, 10 times 7. B is a trapezium. Make sure you know the formula for the area of a trapezium. It comes up a lot. And C is a triangle whereby the height is 6 and the distance here is t minus 12. So again, pause the video, make sure you're okay with all that because it's a problem squeezing all this in. Always be careful not to make silly errors with your algebra. So don't be worried about writing a bit too much out. If you know your stuff, time is not an issue in GCSE. So 10 times 7 is 70. Half of 16 is 8 times 5 is 40. Half of 6 is 3t, and 3 times minus 12 is minus 36. Collect my numbers, and remember all of that is equal to the distance, 5.96t. Take away 3t from both sides, divide by 74, and that gives me 25 seconds. Now, it's not always the case, but I will say if you're doing some maths and you've got things like decimals in the maths, and then a nice number falls out, That's probably a good sign you've got the right answer. Not definite, but it's a good sign. So first question, 25 seconds. Next part of the question, find the rate of deceleration from t to 20. In other words, what's a gradient of this here? So it's a gradient question. Well, I'm going to go down 6, so my change in y is minus 6. And I'm going to go from 12 to t, where I know t is 25, so that's the difference between these two is 13, so therefore it's going to be minus 6 over 13. Now, bit of a weird one here, because the question says what's the deceleration? It doesn't say what's the acceleration. So therefore the deceleration is going to be 6 over 13 meters per second to the minus 2. Nice question. A little bit of a tricky bit at the end. You might get away with it in the exam as long as we can see working somewhere. Well done if you got all those. As ever, do like the video, leave a comment, subscribe to the channel. Helps me and frankly says thank you for putting all these videos up, and I will talk to you again soon. Thanks all.